After I finished hooking up this living armor enemy here, I kind of wanted to be able to give him a way to be able to turn before he ran into the eventual wall that he'll hit. Dang. Okay. So how do we build something like that in our enemy AI? Well, the solution I'm going to propose today is a simple one where we can add a PatrolLimit node to our enemy, and then his state machine will be smart enough to know to hook up to those PatrolLimits if they're present, and if not, then he'll continue to walk to the edge of the map like he does currently.
Hi, my name is Michael. Join me as we build an epic Metroidvania game in Godot 4 using GD script. This is the Metroidvania Forge.
Okay, so the PatrolLimits, what are they? How are they going to work? You can see I've got my living armor here, and you can see also that he's got a little left and a right limit, okay? And these are going to be really simple nodes. They're going to display a little sprite so that we can see which side they are. And I mean, you can see I've got some side options at top and bottom that we're not going to use, but just ignore those for now. I'm using one of the built-in side enums, and so it's got those 4 sides that we can use, and maybe some of you want to utilize those, so they're at your disposal. But we'll be building these, and what these limits are going to do is they're going to just be placeholders. They're going to destroy themselves when the game starts running so that they won't cause any issue there in your game. But then we're going to go into our enemy's script, and we're just going to make our walk state smart enough to recognize if we have limits, and if so, it'll record them, and it'll utilize them to tell our enemy if and when he needs to change direction. Okay, so that's really what we're going to be doing in a nutshell. It's going to be pretty straightforward, and so if that's something that you want to do, then stay tuned. So first thing, go ahead and grab the updated downloads file for Chapter 5, Enemies. If you check out the itch.io page, I've updated that at the time of this recording. So that file now includes a few new assets, and I've already brought those into my project. And so you can see down here, my general, I've brought in 2 things. So there's a new icon. It's this little PatrolLimit icon right here, the little red and white pointer. And then I've got down below in the sprites folder, a new PatrolLimit PNG. Since this is just kind of a general use sprite, and I'm not going to have a folder for this node, this is just kind of where I'm dumping it. Okay, so those are the assets that you'll probably want to have as you follow along. And then, as I mentioned, this is going to be a new script. We could build it here in the general, or we could build it in the enemies. I don't know that it's going to make a huge difference, so maybe I'll just make it here in general script. So I'll create a new script, and I'm going to call it PatrolLimit. And I think inheriting a node 2D is probably what we want. And here we go. So let's give it our class name. And now this script will not need a process function, so I'm going to go ahead and delete this. And we do want to configure it with a few things. So first of all, this should be a tool script because we need it to kind of do some stuff in the editor so that it gives us a little bit of feedback as we're working with it. And we also can provide it the new icon that we brought in. So let me do that real quick. There we go. And then let's see, I'm going to grab a reference actually here. I'm going to grab a constant reference to that sprite sheet. So I've got to find that in my sprites folder. Let's see, general sprites, here it is. PatrolLimit, I'm going to just bring this in here. So we are going to preload that so that we can use this sprite. And then lastly, we're going to export a variable because we need to be able to determine if this particular limit, when we drop it in, if it's a left or a right limit. And so we're going to use a variable called side. Now we could create a new enum, or we could use an existing enum. And I'm actually going to use an existing one because otherwise we'd be hiding it here in the script. It's got the same name, side. So this side already exists. And so you can see that it has side bottom, left, top, or right. Okay, so by default, I'm going to set it to side left. We're not going to use top or bottom, although you could, and this code could work for that if you needed to. Obviously, it would need to be extended a little bit, but there we go. That's all we really need to do to set up the script. Let's set up this ready function. Because this is a tool script, obviously we want some of our functionality to happen only in the editor and some of it to only happen in the game and not in the editor. So let's go ahead and set that up. So if engine is editor hint, oops, I almost had it. There we go. Now what I'm going to do here, we're going to have to do something where we set up a sprite so that we have some visualization, because by default, this is a node 2D, and if we were to drop this into a scene, you're not going to really see it except for that little, origin marker, which is not sufficient for what we want it to do. So we'll do something with that here, and then we'll return. Okay. So if it's in the editor, we're going to display something. If it's not in the editor, we're actually going to queue free this. Okay. So if we're in the game, then it's just going to delete this node. Okay. But what'll happen is you'll see, since queue free happens kind of at the end of the process cycle, we're still going to have access to this node for that first tick as its owner is initializing itself. And that's where we're going to hook into it and utilize it. So this might seem kind of weird, but trust me, it should work. Or maybe don't trust me. I don't know. So for displaying the sprite, we're going to create a new function down here. I'm going to call it add sprite. And what we're going to do with add sprite is, just to be safe, because this could run multiple times and we don't want to be adding tons and tons of children, I want to start by just freeing any children that it might already have. So this node is not designed to have children nodes, obviously, by virtue of that, right? So what I'm going to do is I'm just going to say if get child count, let's see. In fact, we could almost just skip this one and move on to the next one, but this will just prevent it from running if it doesn't need to, I guess. So if child count is greater than 0, then we'll just loop through the children and we'll queue free each one of those, okay? So this is just a little cleanup step that we're going to do before we go adding. And then what we want to do is, I'm going to go ahead and save this, and let's actually drop one in. So how this patrol node is going to work is we're going to add it as a child of an enemy. Okay, so we would simply come to our living armor and say Control A. Oop, my dialogue was on the other window. And then we're just going to add a patrol limit right there. Okay. And see, right now, it's like really not very useful. Like it's not super valuable to look at. It would work without any visual, but I just want a visual so that my life is a little bit easier. Okay. You can see that our side options are here: side left, top right. Okay. And we can change that. But let's go ahead and save this and go back to our script. Okay. So then what we'll do here is this add sprite function is just going to add a couple things. Technically, it's maybe more than just a sprite. We're going to add a sprite with this new, this kind of like map location indicator sprite, as well as a label so that we can show if it's left or right. Okay, and then we'll color it as well. So like a left marker will be white and a right will be red. And I know I'm borrowing that from like old audio cable cues and things like that. So for some of you that makes a lot of sense, and for others it might not. I don't know, but that's what I'm doing. And at least it'll be very obvious that they're different. So let's start by creating a new sprite, sprite 2D. So we can just say sprite2d.new. All right. Then we'll add this to the scene tree and adjust its position. Add child S. And I guess not only adjust its position, we need to assign that texture, right? But we brought that in up here, this patrol limit reference. So we'll say s.texture equals patrol limit. And then we can say s.position equals, and position is relative to the parent, right? As opposed to global position, which is relative to the world space. And we're going to position it just up a little bit so that it's, the point of this indicator is at the origin. We don't need to move it left or right because it's already centered that way. So we're going to say 0, -16. All right. That's going to position it just perfectly. Now, if we go ahead and save this and go back to our playground, our patrol limit currently doesn't have anything because this was added to the tree before we had that code. So I'm going to go ahead and delete this patrol limit, and I'm going to add a new one. And don't worry, we'll get it so that that's not going to be too necessary in the future. But if I add a new patrol limit, look, it does nothing. I wonder why it's doing nothing. Oh, let's check our script real quick. I guess one thing is we probably should call this function here in the ready. Okay, so we're going to call this here in the is editor hint portion, right? So we'll just call add sprite. Save it. Dang it, now I got to do this again. Okay, delete the patrol limit. Add a patrol limit. Oh, I added it with the child of the world. So where is it? There it is. It's up there. Okay, but there you see. Now it's got this nice indicator, and you could change the scale and the size of this if you want to, or you don't even have to use this visual, but this is what I'm going to do. I mean, right now it's a little bit big, but at least it's obvious, right? Now, if I go back to my script, that's for the most part pretty good. I mentioned I want a label, so we'll put like an L or an R, depending on the side that we have selected. So let's go ahead and set that up as well. So I'm just going to call this label L, and we'll do kind of the same thing. Label.new. We can just add this as a child as well. So add child L. Now I need to configure this just a little bit. This label, we want it to be centered within this sprite, right? So we need it to be positioned just right. So what I'm going to do is I'm going to configure it so that I set the size. So I'm going to say L.size.x equals 32, because that's the width of that sprite. And then I also want to set the horizontal alignment of the text to center so that the text is center. So L.horizontal alignment equals, and then you can see we've got some options here. So center is the one we want. And then lastly, we'll set our position, L.position equals, and we'll define a new vector2. And in this case, we need to bump it over a few pixels, -16, because it's gonna need to bump over, it's gonna start at the middle, so we bump it over halfway. And then we'll move it up 24 pixels. So that's a -24 on the Y. Okay. So now if we save this and go back to our playground yet again, we actually may not be able to see this very well. Well, we don't have anything in there. Let's keep this going for just a moment. Or actually, let's do this. Let's just comment out this code for the sprite, and let's go ahead and add a new PatrolLimit so that we can see the label, make sure it's working. So Control A, PatrolLimit. Let's do this. Let's go back in here. L.text. Okay, we got to try it again. It needs some text, right? Otherwise, we can't see nothing. Okay, PatrolLimit. There we go. So there's our L. It's going to have an L right there. Obviously, the L's white, our texture's white, so you wouldn't see the L if we hadn't done that. I'm going to delete it one more time. Okay, so this is good, but obviously we need this to be dynamic. It's going to be L if it's on the left, or if it's set as a left side limit, or it will be R if it's on the right. And in fact, we're going to do other customization to these. So let's go back up here, uncomment this code, so that now we're adding the sprite and the label again. And then we'll just do a check. We'll say if our side is side left, then we're going to do things like this. We're going to set our label text to L. We need to give it a color. So I'm going to give it like a dark gray color. So we'll say L.modulate. That's the easiest way, I think. L.modulate equals color. And let's just go with like 0.2 on the R, G, and B. It's going to be a darker gray color. Okay. We also should modulate the sprite. So I'm going to go S.modulate equals, and we're going to use color white on this one, right, for the left. So it's not going to change it, but we're going to reutilize this code if we change the side from left to right. So it is important that we modulate it to the correct color here just to be safe. And then we'll have an else branch. And this is where we'll handle for it being on the right. Now, technically, if you select side, top, or bottom, this will also apply. You could tighten this up, but I'm just going to do it like this, generic. And I'm kind of going to assume that if it's not left, then it's a right one. So what we'll do is we'll say S.modulate. And in this case, we're going to use a red color. And there's a good color here called Indian red that I like. It's kind of like a tomatoey red. And then I'm going to use L.modulate to modulate the text, right? I guess I'm doing this in a different order. But here, I'm going to make the text color.white, which is kind of the default. And then lastly, we'll say L.text equals R, okay? And let's get these in the same order. Let me just move this modulate just because I'm being kind of weird. And there we go. This is how we will set up this node every time one is added. Let's go ahead and go back to our scene and add one more time. We'll add a PatrolLimit. And now you can see that it's got the L text that's visible and it's looking good, right? So I can drag this kind of anywhere in the scene. And then if we wanted to, we could add a second one, and it should be a child of the living armor. I'm going to go ahead and drag this over here, and then we can set it to side.right. But it doesn't do anything when we change that side to the right, right? So let's go back in here. Right. Let's see. And what we need is, let's just use a setter function on our side variable. So anytime we change this, we can also call this add sprite function. So we'll go side equals value, and we'll call add sprite, just like so. And now if we save this and go back, and let's change this to from left back to right. There we go. Now we've got an indicator that changes how it looks. Okay, pretty straightforward, right? And that's really all that this little patrol limit is going to do, because it's really just a visual placeholder. And then when we run the project, right, because we set these to queue free, they're just going to disappear once the game loads. Okay, we don't see them anywhere. Okay, they're gone. And technically, because they're a child of this enemy, they would be moving with him. Okay, so they're really not useful to have in the world. Now, you could do stuff like have code where it removes itself from its parent, things like that. But really, we're using these pretty strictly for the editor. Okay. Okay, so what good does this do, right? What we're going to do is we're going to hook these into our walk state, or alternatively, you could create a new patrol state, which is just like the walk state, but works a little bit differently. But I am going to just add it to my walk state so that it will kind of work by default with those. Okay, so it's not going to be a functionality on our enemy directly, but instead it'll be on these states here. And we're going to take those nodes that we've added and we're going to record their location as soon as the enemy loads into the world. And we're going to say, okay, well, here we go. We've got a left and a right limit, and just record those global positions. And then our state can reference those as needed and have the enemy turn when he reaches that spot, and so on. So in order to test this, I want to keep my enemy in the walk state, and which means I don't want him to aggro on the player. So first, I'm going to go ahead and grab this collision polygon, and I'm just going to scale it way down. So this guy's practically blind, right? He definitely needs some glasses, is all I got to say about that. So he's not going to see the player, so he shouldn't aggro. Let's just test this and make sure. And he'll just stay in the walk state. Should walk right past the enemy without trying to attack. Okay, very good. I feel like he was walking faster, like, oh, he can hear me, I think. I don't know, can he hear me? Do I have the hearing turned on? Yeah, use audio sensor. I'm going to turn that off. That's why he was aggroed at first, because he heard me fall. Okay, there we go. So he can't detect the player right now, which is good. Or he can, but not very easily. And what we're going to do is, like I mentioned, we're going to go into our walk state and we're going to utilize these here. Okay. And what we're going to do is I'm going to just make some variables really quick, and it's going to be a left limit, which is a float, and we'll have a right limit. And these are what we'll use to record that global X coordinate. Now you could make these a vector 2 if you want to do it in, 2 dimensions. So this could be a vector 2. All right. And you could just store that. But I'm going to keep it as just strictly left and right on that axis. And then let's create a function down here, and we'll call it set limits. Okay. And this is a private function. We don't need to call it from without or from outside of this class. So I'm going to put an underscore on it. And what the set limits is going to do is it's going to check to see if our enemy has any patrol limit nodes. And if it does, we'll record the positions. Okay. Now this code is going to be somewhat generic. And so if you have like 2 left and 3 right limit locations, it's really only going to end up recording the left and right limit of 1 each. Okay. So if you need multiple for some reason, then you would have to kind of change how the script works. And so maybe instead of just a simple variable, maybe you've got an array of limits or something like that. But I'm going to keep with this simple. And we're going to also build this so that we assume that maybe we didn't assign any limits, because by default, maybe you don't. And because we want this to be a modular kind of a system where you could just drop an enemy in and he'll just walk left and right across the whole level, right? We don't really want you to have to put limits on there. They're optional. So we'll start by setting our left limit and right limit to just a default value that's very high, so that it's higher than pretty much any level that they'll be a part of. So what I'm going to do is I'm going to grab the owner.global position. So this should be our enemy scene. And as I'm typing this, I'm realizing something that I'm actually not 100% sure why this works, because maybe we should be using get parent, because this is not going to be a child of the enemy scene itself. It's going to be a child of the enemy scene node within another scene tree. So I feel like get parent is actually more appropriate, but I have tested this in owner works. So let's go with owner for now. Left limit equals owner.globalposition.x. And in this case, we're going to minus 5,000. So it'll be 5,000 pixels to the left. And if your world is even larger, you might need that number to be larger. I'm going to copy and paste this, and then also set a right limit in a similar fashion. But in this case, instead of subtracting, we will add 5,000. Okay. So what that code will do is if we're looking at our playground, it's going to say, okay, what is the global position of my dude? And by default, our left limit is going to be 5,000 pixels this way, which is going to be somewhere way, way the heck over here, and 5,000 to the right. Okay. And again, your mileage may vary. If you've got really large levels, might need to adjust it. Okay, I'm going to come back here. And then after this, what we can do is now we can go through and check and see, do we have any patrol limits? And if so, then let's go ahead and let's set the limits. And you know what? I just realized why this works. I was thinking for a second while I was writing this, I was having a brain fart. I was thinking that this script right here that I'm working on is the patrol limit script, which is not owned by Living Armor. But actually, no. I'm working on my enemy walk state, which will be owned by the enemy. So owner works. Haha, answered my own question. Gotcha. Okay, so, but if you were thinking about that, you're probably wondering, what the heck? Okay, here we go. What I'm going to do now is I'm going to go over the children. One of my favorite bits of functionality in Godot, I guess. I use it all the time. So 4C in get children. Actually, this should be owner get children, actually, right? Because we want to get all the children of our living armor or whatever enemy this is. And we're going to iterate over them, okay? And what we'll do is we'll just check if they're patrol limits, and then if so, we'll check the side, and then we can use them to update the left or the right limit. So we'll say if C is a patrol limit, not is patrol limit, like so. Then, like I mentioned, we got to check the side. Then we'll say if the dot side equals side dot, and then yeah, side dot left. There we go. Okay, so we'll just check, is this a left side? If so, we can set our left limit equal to, and in this case, we're going to just take the global position of this node and grab its x coordinate. So c dot global position dot x. Okay, pretty simple, right? And then what I'm going to do is I'll just copy this and add an else and assume that if it's not a left limit, then it's a right limit. And there we go. Okay, so this is just going to go through and it's going to store and record these limits. And then just to prove that this is working, let's go ahead and print out our limits so that we can see, right? Okay, so if this is working, then when we run our game, let's check. We've got a left limit. And in fact, if we look at the left limit and we look at the transform, oh, this is relative, -95, but it's going to be, we'll get something. It's going to be probably 200-ish, I don't know, whatever that is from the origin. And then another 500 or so for the right. Let's go ahead and see what happens. Wah, wah, wah. I'm doing the famous thing that we always do. I created this beautiful function, set limits, and never called it, did I? I mean, I don't think I've called it anywhere. And where we can call this one is, we don't need it on the enter. In fact, we'll probably put it on the ready function. So as soon as this node loads into the scene, we can set the limits, just like that. Okay, let's try it again, shall we? Bloop, there we go. Left, 225, right, 475. Dang, 25 and 75? What are the chances of that? I've got precision mouse movements built in. Okay, so there we go. Obviously, he's not honoring those limits left, but we're recording them, so we know that our script recognizes them. All right, so it's actually going to be really simple to utilize these limits now, because here in our physics update, much like we've got this is on wall change direction, we can just add a couple additional conditions. So we can say elif, and then we want to get enemy.globalPosition.x. Okay, so for checking against the left limit, we need to check if it's less than, right? Because the left is a negative number compared to, well, it's not a negative number necessarily, but it's less than our, players or our enemy's current position, hopefully. And if not, if it's, if our global position is greater than the left limit, then we know we're still to the right. Okay, so here's what we'll do. We'll say if our global position.x is less than or equal to our left limit. And I want to add one additional check in here, because if we don't do this, our enemy could walk past the limit by a pixel or two, depending on his velocity, and then he'll just like jitter back and forth, right? Because he'll turn right, and I don't know, maybe not, but just to be safe, right? We got to be very careful here. I want to check our blackboard. So we have a direction on our blackboard. So if our blackboard dot dir is less than 0. In fact, the way this guy works, it might not jitter, but we're just going to be safe, all right? Okay, so if our direction is left and we find ourselves on the left side of the left limit, then we need to turn around. So we'll just call enemy.change dir. And in this case, we'll just tell it we want to go to the right, 1.0. Okay, and then we can kind of copy this whole bit of code and paste it here. Now we just need to change this. If it's greater than or equal to the right limit, and the blackboard direction is greater than 0, then we'll change our direction to -1. Okay, this should be enough to make him work. So let's review where we've placed our limits. And in fact, I'm going to move the living armor right here. And then I can drag these patrol limits. We'll put them currently, just to test, we'll put them right on these 2 torches, or maybe right before. Okay. Like so. So now we should see the living armor going between those 2. Ready? He walks is so slow. Boink. There we go. Turned around. So pretty straightforward, right? Now, a few things that I'm going to offer you as homework. There are some ways that we could improve this. I think that the turn is really abrupt and really fast. And for the most part, that might be fine. But you can resolve this in one of 2 ways, I think. One might be to introduce a new state where you just idle. And so maybe if you're patrolling and you reach a patrol limit, then maybe they enter the idle state for some predetermined amount of time, like a second or something like that, and then they turn. That would be kind of fun. Alternatively, what you could do is you could add a turn animation. Maybe you just build that into your walk state so that all you have to do is play the turn, and then when it's finished, you resume playing the walk animation again. But I think that would be kind of fun too, and then you could just keep him. He doesn't have to stop at a location, okay? So I think those are 2 good options for you. Now, if you're using this sprite sheet, he doesn't have a turn animation, so, obviously that one is kind of involved, but so is building an idle state. Either way, they're going to be exercises that are going to stretch your abilities and help you wrap your head around how this system works. All right, that's the video for today. Thank you for watching and following along. And if you have any comments, please feel free to drop them below. Also, I want to invite you to join the Discord or even join my Patreon if you want to support me. You can find links to all of that kind of stuff down in the description below. And anything you do to support me really helps this channel keep going. So like the video, subscribe if you're new, and as always, we'll see you next time.